talk about lasers, but not only am I going to talk about lasers, but I'm going to talk about laser weapons. So I'm going to tell you how to use a laser to, as a weapon. And what I really want to do is I want to demystify laser weapons, because I know all of you might have heard of, sharks with lasers on their heads. I get that all the time. I am a laser engineer, so I worked for an aerospace company for about 6 years developing lasers, and I want to educate you and let you know what it's really about. So this will be my attempt. And first I want to give you sort of like the vision. I don't know, who here has seen Real Genius? Oh, yeah. So this is sort of the military's vision. It was made in 1985. This is a satire. This was a couple years after Ronald Reagan gave a speech on the Star Wars program. So it was this sort of ambitious program to utilize lasers and other ultra advanced technology to protect against missiles. That was a big threat at the time because of the Cold War. And this is a satire of that sort of time. But it's actually not that far from reality. I mean, there are military officials, there are government officials that do sit. I mean, I don't know if it's they have exactly a table like that. But they are interested in bringing laser weapons to the warfighter, as they like to say. But before we go into detail about that, I want to talk about energy as weapon. So a laser is called, it's one of many directed energy weapons. So energy can be used as a weapon. Who has seen this equation before? E equals mc squared. So this is something that Einstein came up with. And this is actually a really powerful equation because it enabled nuclear bombs. So this is Nagasaki. This is a picture of the Nagasaki explosion. And this is serious stuff. So the reason that E equals mc squared is so powerful is because you can have something with not very much mass, like an atom is very light, obviously. But it has a lot of energy because c, who knows what c is? Speed of light. Exactly. So c is the speed of light, and the speed of light is really, really fast. Nothing can go faster than the speed of light in the universe. And so because of that, even though you might have an atom that weighs almost nothing, you have the atom traveling at this speed of light, and that can create a very powerful explosion. So what you may not know is that energy equals h nu. Who has seen this equation before? One per the physicist, 2 people. So this is actually a very good equation too, equals h nu. So photons have energy. So photons are particles of light. And particles of light have energy. So the sun, produces photons, and that has energy. But photons don't have mass, so they don't have any mass whatsoever. But they have a lot of energy, and their energy is related to their frequency. So h in this equation is a physical constant called Planck's constant, and nu is the frequency. So the color, basically the color of light. So different colors of light have different energies, and so with this you can make a laser weapon actually, and so. So light has energy, and energy is power, and so you can use that as a weapon. But there's a reason. I mean, it's not just any type of light. It's coherent light. So, a 50-watt light bulb is perfectly harmless. And the reason it's harmless is because it's incoherent light. So just like the light from the sun, the light is it's across all wavelengths, so it's all different colors of light. It's all different directions of light. It's just all over the place. It's a mess. It's a total mess, which is what this shows in coherent light waves. So a laser is coherent light. So all the laser light is propagating at the same wavelength, and it's actually very dangerous. You don't want to be in front of a 50-watt laser. So it's not, the video I just showed you, that was like a 15,000 watts. So that was a much more powerful laser, but a 50-watt laser is still dangerous. That would burn you, and that would cause very, very bad effects. So you don't want to be in front of a 50-watt laser, but that's why lasers are so powerful. But there are lots of different types of lasers. Lasers can do almost anything. You know, you can make a DVD player. There's a laser pointer. I have one here, which is shaped like
the one you have there?
What?
What's the wattage for the one you have there?
The one I have here is like 0.001 watts. It's like almost nothing. But it can still hurt your eyes, so you still want to be careful. You don't want to like just shine it. Like it would be bad if you just like set it up and you shined it in your eye for long enough. You would do damage. But it's illegal to audience scan with even a laser pointer. So the most a laser pointer can be is 0.05 watts. And it's illegal, actually, it's illegal for me to like shine this in your faces. But that doesn't stop people from doing it. There's other types of lasers. There's free electron lasers, which requires a particle accelerator. So that's kind of an intense type of laser. There's a gas laser. You might have seen like a Heaney laser in your high school physics lab. And there's these chemical lasers, which these nice men are working on. And this is like a stock photo from Northrop Grumman, and this is actually installed on an airplane, much like this airplane. This is the airplane that it's installed on. I got this from Boeing, actually, which is another partner on this program. But they're basically in a Boeing 747. They have 6 of these modules, which is a chemical laser, sort of paired up to produce, to basically shoot down a ballistic missile. You also have solid state lasers, which have just sort of become popular in the last 10 years, and they're very great because, from the military standpoint, because you just plug them in, and you don't require, like this one, you have to have all these really nasty, like see all these tubes, it's basically plumbing. Like you have to be a good plumber if you want to be a laser scientist. And all this tubing has just nasty chemicals that you don't want to be anywhere near. Whereas the solid state laser is very clean, you just plug it in and it just goes. So it's less powerful, but it's a lot cleaner. So I gave it away. So who knows what laser stands for? So it's light amplification through stimulated emission radiation. So that's a really long phrase, but all that it means basically is that you take a gain, what they call a gain medium. So in this case, it's a laser rod. It's just like a little piece of crystal. It might be like that big, and it's just this material that you pump full of energy. And that's the stimulated emission. You pump it you just pump the hell out of it. You just pump it with energy, and it stores all this energy basically until you put mirrors around it too to create a cavity. It's basically you're trying to trap the energy with these mirrors. So you have this thing that you're pumping with all this energy. You put mirrors around it to trap that energy, but not too much. One of these mirrors actually is like a two-way mirror, so it leaks some of the light, and that's important. So the mirrors trap the energy, but let some of it leak out, and then you want to always have laser safety. You want to be safe, so you've got to put on your laser goggles. But once you do that, boom, you take out your target. So this is the airborne laser. So this nice laser pointer I have is actually, I got it from the contractors that have made this system. And it's a highly modified, to say the least, Boeing 747 that they've just stuffed full of laser equipment, and you can see it's engaging with a missile. So that's a ballistic missile, you know, from the Cold War that it's shooting at with the laser. And it's a really complicated system because lasers don't propagate really well through the atmosphere, so they have to have this whole system where they have another laser that like subtracts out the atmospheric distortion. So the whole system takes up an entire plane. But ultimately, they can actually destroy a ballistic missile. And this is just a cartoon. But almost a year ago today, they actually did this. This is a real test. So this is an infrared camera, because you can't actually see the beam, but this is an infrared camera that is showing, that's the laser hitting the missile. And so, this airplane took out a missile about a year ago, and this is an infrared camera. So you can see that this is the plane, here, and this is the missile, and you can see it getting brighter as it's destroyed. So this is real. There is one flaw in the science of real genius that, it's sort of this nice purple laser in the movie scene that we saw, but it's actually invisible. So that is one flaw. But these guys, this is a very typical, I've been in a lot of labs like this, and this is very typical, actually, even 25 years later, 30 years later, it's a very similar looking lab. So now let's move on to the future, science fiction. So what about ray guns versus lightsabers? So maybe some of you love lightsabers. I don't really understand. I don't get them. I don't, when was the last time anyone had a sword fight with a sword? But soldiers still shoot at each other. And I just think it's kind of ironic or something that Obi-Wan is he's all about his lightsaber. So with a lightsaber, the problem I have with the lightsaber is that lasers go on forever. You can't just go and then it's like that and it ends there. Lasers go on forever, but you can actually kind of shoot them in pulses like that. So that works out.
Did they ever actually say that a lightsaber is a laser?
Well, okay, so that's another argument. It's a plasma, some kind of a plasma weapon, which is fine. I mean, you can contain some kind of a plasma in that sort of footprint, but it's not gonna. I don't know. I don't get it.
It's like casting crystals. That's what they're saying.
So even all my criticism of the lightsaber aside, you can get a lightsaber. This is something that you can buy. It's a novelty, but it can hurt you. It's called a lightsaber. They market it as such. It's $300, so you can go order it online tomorrow. It's a blue laser, but they're not going to issue them to soldiers anytime soon. But this is, it's basically, it looks like a lightsaber and you can shine it, but it's not going to, terminate after a meter or something. It's going to go on, and you've got to be careful because these things aren't regulated, and it can damage your eye. This, on the other hand, is a real military potential, system. It's called a phaser. It's these complicated acronyms the military loves to use. It'll startle you temporarily. So the military doesn't have laser guns that will actually hurt you, but it will. They're starting to use them a lot just to get people to stop. Like if there's an enemy coming towards you, you shine the laser at them and say stop. So that's it's not as exciting, but it looks really cool, but it actually is not that exciting. But this is what everyone's interested in. We don't have sound here, but basically Dr. Evil is telling Austin Powers to go into the tank, and there's a very awkward moment because he says, and there's going to be sharks with lasers on their head, and then his assistant is saying, giving him the horrible news that actually they couldn't get the sharks because they're endangered, and so that was a big problem. And this is his angry sort of monologue is all he asks is for freaking sharks with freaking laser beams on their head. And he's very upset about it. And I have to be honest that I kind of agree with him because it's not that difficult. It's seriously like, you know, you could get one of these green lasers. This is a half a watt green laser. You design some kind of a headpiece, and then hire a trained professional. I met a woman recently who works with sharks, and I talked to her about this. So, you know, it's actually like lasers have gotten small enough and efficient enough. It's all about efficiency, because like, you know, they're efficient enough that you can just power them with a battery instead of like a whole room full of, of batteries. So it's really not a big deal. Well, the issue. So that's a great question, because the issue is how well is the laser going to propagate? Because lasers don't really propagate well in the air. You have to build these complicated systems to like remove the problems. And it's the same underwater. Although with green light, there's this is the absorption spectrum of green light. So this basically absorbs no light. So it propagates really well. Like the higher this curve goes, like the less the laser can move through the water. So the lasers at about 1,000 nanometers would not move well through water. But the green is not a bad choice. And then this is sort of, this shows you how lasers don't propagate well through air, because like as you can kind of see with heat sort of also affects your vision. It also affects lasers in a similar way, because the air acts as these tiny little lenses that kind of mess up your laser. And that's a big problem. So, and this is my little takeaway. Light interacts with matter. So even though photons don't have mass, photons interact with matter. That's why we can see. And that's the reason we can do a lot of things with lasers and other sources of light. So that's a really important thing to remember. On the other hand, lasers are perfect for space. They were sort of meant to be in space. I mean, this is the kind of crazy, kind of weird thing that I think about, because they're really perfect for space. So it's a technology that spacefaring civilizations really, would need. But they're still dangerous. I want to, just make sure you understand that they're very dangerous. It depends on the wavelength, but like visible lasers are dangerous, but you can see them, so you can kind of like, if you can see it, you can protect yourself against it. But the most dangerous wavelengths are the ones you can't see, which is infrared, which is kind of like 1,000 to 1,400, because it'll go through your eye and just attack this area. So you need to wear your laser goggles. And these are just point home more. And this little like that's the laser humor. Joke. And then this is sort of a technical slide, but the profile of the laser is it happens to be a Gaussian, and this is sort of the most powerful part of the laser is in the center, and this is a pretty laser. So the aesthetics of lasers is what I'm trying to show you here. So this is a pretty laser, this is a bad laser. You don't want that, you want this. This is very pretty. And if you have a pretty laser, then you can do this. So this is an airborne laser system, not this one, but sort of a precursor to it, lighting the hood of a truck on fire. And that's kind of the interesting thing. Is like lasers don't make noises, or not the noise that you would hear, and you can't see them. It's just sort of like something spontaneously combusts, like it could actually be from an invisible laser. This was like done about 2 years ago, I think. So laser weapons are like ninjas. Invisible, silent, deadly.